Okay, it is time for our final lesson in this massive unit that has been parabolas. So we've talked about a whole bunch of different equations involving parabolas. We've graphed them. We've converted them to different forms. But one thing we haven't done too much is look at kind of more details about parabolas themselves. So today we're going to take another look at parabolas in a little more detail. We're going to get a little bit more technical information about how they work, and we're even going to actually get some vocab. So first things first is to kind of draw a slightly new picture of a parabola. So I'm going to start with a fairly big parabola here. Here's my vertex. And I have a parabola coming off of it. So when we've looked at the parabola before, the only real information that we paid attention to before was our vertex, which we knew that one. That's the base of our parabola. And we looked at our axis of symmetry. The axis of symmetry being that straight line coming right down the middle, going through the vertex. So this was our axis of symmetry. However, there's a whole bunch of weird information about parabolas. So we have several other interesting things about them. So one involves the distance between two more pieces of parabolas that we haven't really dealt with before. So first is this vertex lies equally between two key points. We have something called the focus, and we have a line called the directrix. So we have a focus, and then equally distant from the focus, in the vertex, we have something called the directrix. And the directrix is going to be a horizontal line. So this gives us two more pieces of information. So again, a directrix is this horizontal line, and then we have a focus. Our first key piece here is that distance between the focus and the vertex, and the distance between the vertex and the directrix, that is the same distance. That distance is always exactly the same amount. Now, there's some weird facts about these. So, as an example, if I look at the distance from any point on the parabola, that distance from that point to the focus and to the directrix is actually going to be equal. Obviously, my parabola is not drawn very well. This guy should be a little bit wider. Again, that distance from the focus to the directrix is going to be the same all the way throughout. So that's another key piece of information. So the distance from here to here is going to be the same as the distance from here to here. Next interesting piece is that these distances, while always the same, are particularly the same here, and we're going to usually call that distance a letter P. I have no actual idea why they use the letter P for this, honestly. It's one of those things I've never really looked up or figured out, but we almost always use the letter P for it. So all of this is used to teach us a bunch of different things. So we're going to look at a new version of our basic formula for parabolas then. So our new standard form is going to look a little bit different. So we've had a whole bunch of different equations. We've had our standard form, y equals ax squared plus bx plus c. We had our, intercept form, which is y equals a times x minus p, x minus q, where p and q in this case were always going to be the intercepts. We used our y equals a times x minus h squared plus k. We had that one. So now we're going to add something a little bit different. And what we're going to do is we're going to describe the parabola in terms of this distance p between the directrix and the vertex, or the distance between the vertex and the focus. Now, if the parabola is centered at the origin, this is relatively straightforward. So our new form, if it's at the origin, is going to be x squared equals 4py. That's kind of it. I know it doesn't seem like much. That's about what we got. So if we wanted to take a look at this and compare it to, say, our standard parabola, where they ask, well, y equals x squared, then we could actually compare it to this to figure out what the p is, the distance, and to figure out what the directrix and the focus would be. So we're actually going to try that as our first example of using this new information. So let's take a look at y equals x squared, our most basic parabola, the first one we learned, the parent graph that we worked with. So what I'm going to do is I'm going to compare this to our new formula. Our 4py is equal to x squared. And what I'm going to do is I'm going to kind of match up the pieces. So I have an x squared, I have an x squared, I have a 1y compared to the 4py. So I'm going to use that relationship to actually showcase what p would have to be. So that 1 that we have here would have to be equivalent to 4p. So we can actually solve for the p, and we'd find that the p for our basic parabola is 1/4, or 0.25. So it's not very big. The distances from the edge of the parabola and the vertex or the directrix are not large. If I were to now graph this, I'll kind of make it zoomed in a bit here. Our basic parabola is at 0, 0. It passes through 1, 1 on each side, and then it would be 2, 4. So here's our basic y equals x squared. If we were to look at this now, we could actually try to show the focus in the directrix, but it is not far at all. So if I know here's my vertex, the focus is only a 1/4 unit up. So my focus is the same as that vertex, but plus the p-value. So if my normal vertex here is 0, 0, my focus is in fact 0 and then 1/4. It's just a little bit higher up. My directrix, that line that kind of centers the parabola, is actually just that p-value down from it. So my directrix would have an equation y equals -1/4. It's actually just moved down 1/4 from the vertex. And this is our basic way that we're going to look at the parabolas. So if I have a generic parabola, and I have my vertex, here's my HK from when we talked about the vertex of a parabola. Then if we want to find the focus is simply going to be moved up p units from our vertex, from our H and K. So my focus then is going to be the same x value as the vertex, but just moved up that tiny bit, k plus p. My directrix is down that same amount p, and it's a horizontal line. And that line is going to have the equation y equals, well, instead of k plus p, we're going to go down, so that's going to be k minus p. So notice then that this is actually going to be able to control where we go and what we get this information. So let's try one more case of the simple one, and then we'll expand out to our full H and K definition. So how about we had something like y equals 4x squared, and we'll go with this. Nice basic one, y equals 4x squared. And we wanted to know, well, what's the focus? What's the directrix? So to find these, we need to know the p-value. We need to know how far from the vertex do we find the focus and do we find the directrix. So I compare this to my basic graph again. So remember, it was 4py equals x squared. So now, in order to find it, I need to compare them to each other. So notice here on my y equals x squared, or my y equals 4x squared, it's not a direct comparison yet. To make it work, I'm going to have to divide both sides by 4, so x is by itself. So now I have y over 4 is equal to x squared. Now we can directly compare each other. So I have the x squared, I have the x squared. So I'm saying that 4py has to be the same as y over 4. So that's what I'm going to look at now. So 4p has to be the same as 1/4. So all I've done is I've compared what has to be next to the y value for us to compare it. Now, essentially, what we are doing is actually trying to solve for p. So in this case, I could divide both sides by 4, and I'd get p is 1/16. And this is going to be kind of a rule of thumb. The skinnier the parabola is, the smaller that p-value is, the closer in the directrix is. If we have a really fat parabola, then we're going to get a much bigger p-value and a much larger distance between the vertex and the directrix. So with something skinny like y equals 4x squared, my p-value would be really close, 1/16. So small, it'd be really hard to even show it. So for our example here of y equals 4x squared, then, we know that the vertex is still 0, 0. The focus is going to be moving up that p-value. So our p is 1/16. So my focus is 0, 1/16. My directrix is moved down from it. So there's going to be a y of, and if I move down 1/16 from 0, that's going to be a directrix of y is negative 1/16. So you can see these can be some really small p-values. So let's look at one more case where we're going to get something a little bit fatter. So how about we're starting with y equals 1/5 x squared. We know this is a much fatter parabola, so maybe we can get a p-value that's a little bit easier to see. So again, my general form for an easy one is 4py equals x squared. And we need to compare them. So before I can compare, I need the x squared kind of by itself. So I'd multiply both sides by 5. So that gives me 5y is equal to x squared. Now that we're both comparing x squared, we can actually kind of compare things. So we're saying that 5y would have to be roughly the same as 4py, because we know that these are equivalent expressions. So my 5y has to match up with the 4py. So now we're saying that that 5 has to be the same as 4p. Divide both sides by 4, and I'd get p is equal to 5/4. Okay, that's a bit better. So notice again, even with a much fatter parabola, 1/5, we're still not seeing a very big distance here. This is just 1.25. That's as far as we got with something as wide as 1/5 x squared. It takes a really, really wide parabola before this becomes really noticeable. So let's take a look at this. So if we have a p-value of 1.25, I know my starting vertex for y equals 1/5 x squared is still 0, 0. So my focus would be moving up from there, and it would move to 0, 1.25. My directrix is down from the vertex, so it would be y equals negative 1.25. So now we've kind of looked at identifying the vertex and the directrix given a parabola. I'll talk about what this is used for in a little bit. We're now going to look at kind of the full version of the entire equation, which is just a little bit more. So just like when we were looking at parabolas originally, we talked about y equals x squared as a parent graph. This is almost similar to a parent graph ideal. This is still our basic idea of, this is just a simple case, but we can move it around somewhere. So now that we've done kind of the basics of this idea, let's look at the full formula. If I have a parabola that's moved anywhere, let's draw this nice and big so we can see it. And I have that parabola, let's say it's nice and wide, so we can kind of get a better visual image of some vertex, hk, that we don't know. we know that the focus would be some distance p above it. So that focus would be found at h, k plus p. And that's a little bit hard to see. So let me write it out a little bit bigger. So my focus is going to be h, k plus p. The directrix is that same p distance down and is a horizontal line going sideways. And that's going to be at y equals k minus p. So we're going to move p up to get our focus, p down to get our directrix. So our general case now, if we're not centered at the origin, and this is kind of the full formula at this point. Is x minus h squared equals 4p y minus k. This is our full big ugly version of the parabola equation. This is the version that gives us the most information. We can still find the focus. I'm sorry, we can still find the vertex. Our vertex is still hk. That's easy enough. We can tell what direction it opens up because p being positive takes us up. If p was negative, it would actually reverse it. We would go downwards. So we have all of our information. This is the final accumulation of our whole unit on parabolas. This is our full formula for a parabola now. So I'm just going to do a couple examples. We'll go from a couple formulas looking at it to talking about what it would be look like. We'll graph it by hand, although you can just put it into any device. We'll identify what the focus of the directrix is, and then I'll reverse it. We'll say, okay, if it has certain information, how do we find the equation? And then we'll talk a little bit about how this is actually useful. So let's look at an equation. So how about we started off with something like x minus 2 squared equals 8 times y plus 3. Okay, so here's a generic form of a parabola. I'm going to compare that to our basic formula. Remember, our basic formula is x minus h squared equals 4p y minus k. So I can directly compare them and figure out what each key piece of information is. So I know by looking at the x part that my h is 2. I know from looking over here that k is negative 3. It would have to be the opposite sign. So my vertex of this parabola is 2, negative 3. I compare this piece here to actually figure out what the p-value is. So 8 would have to equal to 4p. So to solve for p, I can divide both sides by 4, and I get p equals 2. Since p equals 2 and I know the vertex, I can now define the focus. The focus would be moved up 2 units, so my focus is at 2, negative 1. My directrix is going to be y equals, and it's going to be the p-value down from that vertex. So negative 3 minus 2 would be negative 5. So y equals negative 5 is the directrix. If I wanted to sketch a graph then, I identify my vertex first. 1, 2, 1, 2, 3. There's my vertex. Next, I plot my focus. My focus is at 2, negative 1. That tells me the parabola is opening upward. My directrix is y equals negative 5. 2 more. There's my directrix. So my parabola would look something like this. I have my vertex, I have my focus, I have my directrix. All right, what if we wanted to go backwards? What if we know information about a parabola, but we need the equation of it? Well, what if they tell us that the vertex of a parabola is something like -2, 3, and they tell us the focus is at -4, 3. Now let's do -2, 5. I think we'll do that one. All right, so if I'm going to try to figure out the equation of this, I'm just going to sketch, and I'm not going to try to graph. I'm just going to sketch it real quick. See, I'm not even going to try to be neat with it. So my vertex is over here at -2, 3. There's my vertex, and it tells us the focus is at -2, 5. So just looking at that and comparing them, I can see that my P is equal to 2. I know the vertex gives me the HK, so H is -2, K is 3. And that's enough information for us to put the formula together. So remember, our basic version is x minus h squared is equal to 4p y minus k. So now I can plug in each piece of information. So we get x plus 2 squared has to equal 4 times my p-value of 2 times y minus k, which is 3. And we can then just simplify a little bit. And we get 8 times y minus 3. And it's okay to leave it in that format. It's one of our standard forms. You don't need to multiply it out anymore. We can just leave it like this because this is a more useful form for us. This then would give us the defining characteristics of the parabola that we have. So we can go back and forth between them. Any of you that have like a satellite dish or anything, a lot of those form what's called a parabolic reflector. So parabolic reflectors operate because if I have a nice parabola and light is coming in, or energy or anything else, when it hits, it actually reflects. And it turns out that all of those will end up reflecting at that same point. So as the light comes in, it ends up reflecting toward a center given point. That point is the focus. So when we look at satellite dishes, they'll often have that little device up near the, like away from the center to help actually catch the reflecting information. If you've ever in like a science class in grade school made a parabolic oven where you have a little parabola shape of foil and it heats water above it, it's the same principle. So this is something that's actually fairly useful for us. Knowing the equation of the parabola lets us plot out where the focus point would be, and we can actually build a reflective mirror. This is the same kind of idea as your contact lenses almost. By having a certain shape to it, it adjusts where the light focuses. In the case of parabolic reflectors, that shape happens to actually be a parabola. So let's do maybe one more example, and then I'll kind of talk about what your homework might look like in this lesson. I'm not going to ask you to graph too much. I'm mostly going to ask you to find useful information about things. So let's say one more. We want to find the equation of a parabola that has, I don't know, let's not get the vertex this time. What if we have a focus at 1, 5, and we know the directrix is y equals 1. All right, that doesn't seem like a lot of information, but this is still sufficient enough. So again, I'm just going to start by loose sketching it real quick to get an idea of what's going on. So I have a focus at 1, 5 up here, and my directrix is at y equals 1. So that actually allows me to kind of compare. So the distance from here to here, we're up here at 5, this is y equals 1, this is a total distance of 2. My vertex has to be exactly in the middle. It has to be in between them. So my vertex is actually going to be at 1, 3. We're halfway between the focus at 5 and the directrix at 1. Well, if I know my vertex, now that I know the vertex of 1, 3, that tells me that h has to equal 1, k has to equal 3. And now I know that the distance between the vertex and the focus is 2. So p has to equal 2. So I can go to my equation. My x minus h squared has to equal 4py minus k. And I can actually plug in all of our information. So I'd have x minus 3 squared, x minus 1 squared, has to equal 4 times my p-value of 2 times y minus 3. I get x minus 1 squared equals 8 times y minus 3. And that is the equation of the parabola that has a focus at 1, 5 and a directrix of y equals 1. Homework problems will be of a couple things. I'll either give you an equation and ask you to tell me what the focus is and what the directrix is, or I might ask you, I'll give you pieces of information, maybe the vertex and the directrix, maybe the vertex and the focus, and then I'll ask you what the equation of the parabola would be. There'll also probably be 1 or 2 word problems where you'll have to interpret these results and kind of give me information about it. This is it. This is kind of where we're ending with parabolas, is this general case where we can get a little more information about them. Our next class will just be a review day. I'll be posting a practice review. Our first test of the next grading period is going to be just on units 5, 6, or I'm sorry, on sections 5, 6, and 7. It's not cumulative. So we'll just be covering that, and then we can finally move on to something different from our parabolas.